All right, guys. Yes, I'm doing this today. Anyways, what you're going to do, you're going to go to my MCPS classroom and chemistry class. All right? Go to your homepage and you're going to find our lesson for today. So the title is Stoichiometry. Okay? How do you spell that? Stoichiometry. All right? So when you go to my MCPS classroom homepage, go ahead and click on this one. This is your lesson. And this is actually your notes. Okay? All right, so for the first part, if you look in here, it says a mole is simply a. So when you go to your lesson, all right, first of all, the objective, you're going to calculate the theoretical quantity in order to measure the product made by a reaction or of reactant required for a reaction. So when you go to your sheet, it asks you what is a mole, right? So the mole is simply a unit of measurement. The abbreviation for mole is mol, M-O-L. So the first example it says in here, how many grams of carbon dioxide is 0.2 moles of carbon dioxide? Carbon dioxide, remember that is CO2. So one thing that I want to show you, okay? So when you have the CO2, let me write it bigger, okay? So the CO2, if you don't have any number next to C, that means that there's only one carbon, okay? And since you have two over here for oxygen, you're going to put here 2 oxygen. All right? So make sure that you understand when there's no number after the element, that means that there's only one molecule of that element. All right, so let me show you here. On your paper, you're going to see this. All right? So you're going to find oxygen is here, and you're going to see that carbon is here, okay? So we're doing carbon dioxide. Let me go back to the slide. It says in here, how many grams of carbon dioxide is 0.2 moles of CO2? You're going to look first at atomic masses. First of the carbon and following by the oxygen. So remember that the number of the grams is per 1 mole of atoms, meaning that you have the atomic masses. Okay, let's do it together. All right? So in here, the carbon in here, this is the atomic mass for each one. So if you look on your paper, let me try to put this straight. So if you look at the paper, the atomic mass for carbon is 12 grams. Okay? And then if you look in here, for the oxygen is 15.9, which is the same thing as 16 grams. All right? Now it says in here, how many molecules do you see? Again, you have CO2 for carbon dioxide. C is 1 molecule, and oxygen is 2 molecules. Okay? So 1 molecule and 2 molecules, which is not the same as mole. Okay? Be careful with that. All right, let's move on. Next slide. Okay? All right. So you have that, right? We're doing all this. Why are you doing this? Because at the end, what I want you to do, it's basically use the 0.2 moles of carbon dioxide. You're going to multiply that. How is that? I'll show you now. So you told me that there's 12 grams for carbon, and there's 16 grams for oxygen, right? So in here it says it's 44.01. Where did you get that number, Ms. Hoskins, right? You're going to simply multiply the number of grams per mole times the number of moles you have in order to get the final answer. So where did I get the 44.2? So you have only 12 grams, right? And then you have 2, right? 2 16. So you have 16 times 2 equals 32 grams plus the 12 from carbon, okay, that would give you the 44 grams, or 44.1. It's 0.1. It's the same thing. So let me see if I can show you here. Okay? Sorry for doing this way. All right. So this is where you get the 44.01 grams per mole. So what you're going to do in here, you have the 0.2 moles. You're going to multiply that by 44.01, and that would give you the 8.80 grams for 0.2 moles. Okay? You have one more exercise that you're going to be working on your own. Okay? This is my I do. Now this is a we do. So what I want you to do is try during class. Okay? And if you have any questions on how to do it, just let me know. But I want you to try it by yourself first, okay? Because it's basically the exact same thing, only that this one is going to be H2O instead of CO2. So H2O, you know that is what? Water, okay? And then after that, you're going to do this by yourself first. So it's asking you about, you're going to use the periodic table, and you're going to find the molar mass for lithium. Okay, find lithium here, and then you're going to get the answer. Remember that the molar mass is the same thing as the atomic mass. So you already know that the atomic mass is the number, the higher number that you see on the element. So for example, if you have hydrogen, you have here number 1, and then here 1.008. The number that is higher, that's going to be your atomic mass. So in this case, it's going to be lithium. You're going to find lithium, and the higher number, that's going to be your grams per mole. That's going to be your molar mass. So the same thing for the next one. Now in this one, you're going to find the atomic weight. Atomic weight is the same thing as, let me put it in here, your atomic mass. So your atomic weight is the same as your atomic mass, okay? Meaning that when you go to your element, this is a different one, this is boron. Boron, you see that it says 5 and then 10.81. The higher number is going to be your atomic weight, which is the same thing as your atomic mass. So in this case, you're going to find the one that says 74.92 AMU, okay? And then you're going to pick the element here, okay? For the next one, it's going to be the same. All of them, it's going to be the same, okay? This is super easy, guys, but if you have any questions, I'll be here in class in case you need me, all right? All right, good luck.